Hey everybody, welcome inside of Mission Control Houston. I'm Dan Hewitt, one of our NASA Public Affairs officers, and I'm joined by Cinda Chullen, and real excited to take a bunch of questions for you. Real quick about the room that we're in, you can see a great big ground map behind us, a bunch of screens, things like that. This is the Nerve Center. This is where the International Space Station Flight Control Room is actually flown from. We have flight controllers at a bunch of different consoles monitoring things like life support systems, the crew's day, you name it, they're watching it from right here in this room. But with that, we're real excited to get to your questions, so why don't we go ahead and get started?
Okay, what language is spoken at the International Space Station?
Well, there's various languages spoke and in the space station because it's a multicultural environment. We have multiple different astronauts that go there and visit and work there. So at different times, depending upon the astronaut that's there, we could actually be speaking the language that they have.
Yeah, I mean, right now we have 3 Russians on board, so a lot of Russian, and pretty much half the International Space Station is Russian. And all of our American astronauts launch on Russian vehicles, so they all get pretty proficient in speaking Russian. But I mean, you also have Japanese astronauts up there all the time. We'll have an Italian launching later this month, so quite a few languages going on. Great question.
Yes.
How extreme is the weight training that prepares an astronaut to go into space? And I know the other guy was talking about how you lose muscle mass in space.
Well, the astronauts have a training facility that they actually train in. It's kind of like a gym that you would go to, but we've set it aside just for the astronauts. I teach exercise myself. I'm actually in the process of learning Taekwondo from Dr. Stan Love, which is an astronaut. So he uses Taekwondo to keep himself in shape. And they also do different techniques to hone certain skills that they may need. For example, there was just an announcement that was made that all of our astronauts need to be trained to do an extravehicular activity. So if that's the case, they have to be super fit to do that. That's a very difficult task to do, to be in the suit and to work and to operate. And so they do weight training. A lot of them jog. They do very specific training with them at this gym facility. And then they can pick their own things to do, like Taekwondo.
Yeah, and like you had mentioned, losing muscle mass on orbit is actually a pretty serious problem for the astronauts when they're up there. I mean, when you're up there for 6 months at a time, you're floating around, you don't use your legs, you lose muscle, bone mass. So these astronauts actually work out for about 2.5 hours every single day. So we have a number of weightlifting simulation devices on board because you can't really pick something up and lift it because it'll just float away. So they will actually get strapped into harnesses to run on treadmills. We have a device called ARED, which kind of simulates like a squat rack, and a number of different devices that actually uses pneumatic tubes to simulate weight. So they have a lot of options to them, but they literally work out every single day just to combat what happens when you float around in microgravity.
Right.
Next question.
What is the coolest thing you've ever seen while in space?
Coolest thing? Well, unfortunately, neither of us have been to space yet.
We have not, but to me, I'm a spacesuit engineer. So to me, the coolest thing I've ever seen in space is an astronaut going on EVA. That's what we call it, a spacewalk. So whenever they go out and do a spacewalk in their spacesuit, it's cool to me because I know that it's hardware that I've worked on. And when I see them doing the EVAs and they're successful, then that makes me feel successful as well as an engineer.
And I know a lot of the astronauts will talk about it, and you can actually see over the past year or so, we've gotten some spectacular videos of the northern lights and the southern lights from the International Space Station. And I mean, they look spectacular from the ground. They look even better from space. And if you search for those online, you can find them. They're fantastic videos.
You can even see hurricanes.
Mm-hmm. Yeah.
So the biggest hurricane we had in Houston was Hurricane Ike, and they said that they could see it in space. So
basically, everything that looks cool down here looks even cooler from space.
Yes.
Next question, guys.
What is the hardest part about working in mission control?
Hardest part about working in mission control?
Yes, I don't actually work in mission control, but I've actually supported mission control in what we call a mission evaluation room, and that's where we sit on console as a technical expert, so that if there's problems occurring with the hardware, then we can be retrieved to be observant and try to understand what's going on and help solve the problem. In addition to that, of sitting on console, when we do a spacewalk, for example, we have a whole team of people who support the person in the mission evaluation room in case there's anomalies. We have experts all the way from, we have glove experts, we have life support experts, and those people have to be on call when we do a spacewalk. So mission control is not just the people who sit in the mission control room, but it's a whole cadre of people that support them with the technical expertise to help solve problems if there are any.
And I know one other thing just to throw in, probably the most difficult thing when you're first getting used to it is if you can look just behind me here, we have these, and these are our communication devices that kind of get everybody locked in, and we call them loops. And at any one time, you could have 4 or 5, 6 loops punched up and have 4 or 5 conversations going on in your head at the same time. So just being able to kind of keep track of that and think through everything can be really tough right off the bat. But I mean, once you're at it for a little while, it gets a lot easier.
Right. You have to wear headsets like we're wearing today to listen to those lectures or the information that's coming across the console.
All right, next question.
Can you describe what a day in your life is like with the careers that you have?
A day in life of the career that I have? Well, like I said, I'm a spacesuit engineer, and as a matter of fact, I specialize in life support, and my specific responsibility is I'm in charge of the hardware to remove the carbon dioxide from the spacesuit. So when you're breathing, you're expiring carbon dioxide, and that chemical is hazardous to your health. You cannot sustain life with it in your suit, and you probably learned that in chemistry. So what we have to do is supply the oxygen and remove the carbon dioxide. And so the coolest thing is that for me as an engineer working on a life support system is that for the first time in over nearly 40 years, we are building a portable life support system in our laboratory. And I work in that laboratory to help assemble the hardware, and we're doing it all in-house. In the past, the NASA experts have written the requirements, and we've hired a contractor to actually build and assemble the hardware. This go around, our advanced spacesuit, we are assembling the prototype hardware in our laboratories. And just this past week, we did the final assembly of our very first prototype packaged portable life support system. We call it a PLIS. And so the whole team was extremely excited. But my job,
Very cool.
I do all kinds of things. I help, we can't do everything, so we do have contractors that support us. Those are skills that maybe we don't have, and we help. We buy some hardware from them. We bring it in. We build some and design some hardware ourselves, and then we integrate it. So we do systems engineering. We do design engineering. And so we have a whole cadre. So I have a really cool job. Yeah.
My job is to hear about cool jobs and then talk about space. So
Yeah.
really cool stuff. If you guys are ever going to be interested in, building space equipment, building a spacesuit,
Right.
stuff like that, think about coming to NASA.
Yes, it's great.
All right, next question.
Were there any missions that you failed?
Any missions that have failed? Yes, there have been. One of the things with spaceflight is it's inherently dangerous. I mean, when you talk about just a space launch, you're talking about strapping human beings to a controlled explosion, sending them miles up into the air into an environment that if you were to be exposed to it for even a short period of time, you would die. So it's inherently one of the most dangerous things humanity has ever done. And with that, you have to take certain risks, and sometimes things have failed. There were 2 space shuttle missions which resulted in a loss of the crew. And then there was a fire back in the Apollo days where a crew was lost during a testing of the Apollo 1 capsule. So it does occur, but again, that's just kind of part of what spaceflight is. It's always going to be dangerous, but the risks always are worth it. You know, we're moving humanity out, we're developing amazing technologies, we're doing things that have never been done before. So you have to be willing to kind of take that precarious step in that direction if you're going to be able to accomplish everything that we've accomplished.
Yes, and I would say failure for us is, we have to always be cognizant of the spacewalks and monitoring every detail. We've had failures in components on our portable life support system and in the suit, and we have, like I said, a cadre of people that help try to resolve that on orbit. We have resolved failures on orbit. We have resolved failures while we're doing spacewalks. And so that's why it's very good to have these experts there to help solve the problems. We've had failures where we've had to terminate the spacewalk and bring the hardware inside and then bring it home to repair it so that we can use it again.
Yeah. So failures just bring opportunities to work through it and learn something new.
Right.
All right, next question, guys.
All right. I know it was a while back, but what was the hardest part about the Mercury project?
Hardest part about Mercury?
I'm not sure I can answer that.
Well,
I think one of the things is we were really just getting started in the space program, especially for the suits, for the spacesuits. It was the early phases of the spacesuits, and we were transitioning from the development of the spacesuits originated from high altitude aircraft from the Air Force. And so we took those, and in the Mercury program, we did some development that integrated the work that was done in the high altitude suits. And so I think that that was, for us, that was a monumental phase for spaceflight, because we started looking at what we could do with high altitude suits to integrate it into spacesuits.
And I mean, really, that kind of applied to the whole program in general. As you said, we were just kind of getting started. So, I mean, at first you were launching humans on rockets, which up until that point had only launched missiles. And I mean, it was really the first steps that we had ever taken towards putting human beings in space. So you really want to talk about starting from scratch. You had to figure out how to do everything. So it was really a great learning step for NASA and just human spaceflight as a whole. All right, next question, guys.
Are there any plans to expand the ISS?
I'm sorry, we didn't quite catch that.
Are there any plans to expand the ISS, International Space Station?
On the U.S. side of everything, we're done constructing it. It's in its full mode.
Side.
But
any side doesn't matter.
But the Russians, though, are planning on launching a new laboratory module later this year. I think in December. Right now, they're targeting it. But as of right now, it's pretty much construction complete. The station right now weighs almost 1 million pounds. Has enough room inside to equate to basically being a 3-bedroom house. So it's very large. If you laid it down on a football field, end zone to end zone, it would fill up the whole thing. So it's a pretty big spaceship right now.
One of the things I would add is that they have come to us to evaluate how long the spacesuit would last to support this space station, and we have good faith that the suit will support it to 2020. But they've also asked us to look at what would it be to support it all the way to 2028, and so we have done those calculations and looked at the hardware, and so I think Space Station is looking at really trying to build a brand new spacesuit, and we're funded by Advanced Development to do exploration, and so we are just now really collaborating with Station on an advanced suit that they may be able to synergize some of the learning that we've had on the Advanced Development suit that might be able to carry over into a Space Station suit in case we do extend the station longer.
All right, great question.
What has been the most failed mission control has experienced?
Most failed mission control has experienced?
Yes.
I mean, you could almost say, I'm sorry, was it the most failed mission that mission control has experienced? Just want to clarify.
Yes.
Okay. Well, you could probably talk about Apollo 13, which, I mean, that was not only what started off as a failure, but eventually turned into one of NASA's finest moments. I mean, you had astronauts being sent on their way to the moon 250,000 miles away. An explosion happened in one of the oxygen tanks. You literally had a huge chunk of the spacecraft blow off into space while they're traveling almost 20,000 miles away from Earth. And then Mission Control worked through to come up with a number of workarounds to do things like removing carbon dioxide from the
Right.
breathing atmosphere, which is so important. I mean, they really had to work to basically bring these astronauts home on no power, no breathing air, no resupply, no anything. And so that was a very, very difficult mission, but it ended up being, again, one of NASA's finest hours.
Yes, I agree.
Great question.
What has been the most important mission over the years on the International Space Station?
Most important mission?
On board the International Space Station.
Maybe
I mean, that's
assembly?
tough. Basically, the whole assembly of the International Space Station, yeah, like you just mentioned, was probably up there. This is something that, again, has never been accomplished in the history of mankind. We built the space station piece by piece over a decade. I mean, you're launching parts that were constructed all across the globe by different space agencies from different companies, and you managed to work with all of those various national governments and contractors and companies, things like that, to build this massive space complex, which is manned 24/7, 365 by astronauts, a crew from all over the world. So I would basically say assembly, and that was kind of an amalgamation of a bunch of different missions, but that the assembly as a mission as a whole was probably the most difficult.
And it was very complicated at the beginning because the configurations changed over the years in the planning. And so to get it going was very difficult too. And then once we got it assembled, everyone's very proud of that, what we have in space right now.
Great question. Let's get the next one.
What is the future of the International Space Station and how long will it be functioning?
I think I mentioned that a little bit. I don't think that they are assessing it right now, how long that it could potentially last, and they're evaluating all the different components that help make it operate properly, like, for example, the spacesuits. Like I said, we're evaluating how long the spacesuit could last because it's a critical component in keeping the space station alive in case they have problems that they have to go out and fix. So they have to evaluate and they're really in evaluation of that now. So trying to make a decision on how long it really can go.
Yeah, right now we know at least until 2020, but like you were saying, a lot of the systems on board are certified to last until 2028, and some even longer. So it could be up there for quite some time. All right, next question.
Will the new spacesuits be easier to put on and take off?
What?
New spacesuits be easier to take on or put on and take off?
I think so. The new spacesuits, we have them designed so they can open up in the back versus opening up in the where you climb in, like put a shirt on. You'd climb in, you get into it, and you put a shirt on, and then you pull up your we call them the upper torso for the top and the lower torso for the bottom. And the hard part about that is you actually have to have another astronaut to actually help you assemble the hardware when you're in space. So you always have to have the person getting in it and the person helping. The new spacesuit will work a lot different than that. It will be a contiguous suit on the soft side of the suit, and then the portable life support system will still be on the back, like the system like the spacesuit we have today, but the hatch will open from it'll be on your back, and it will open up just like a door, and the portable life support system will be in that door, and you can actually crawl into the spacesuit yourself. Now there will be some manipulation that someone will have to do, an astronaut will have to do on the inside, but it won't be as rigorous as it is today. So it should be a lot easier.
Great question.
Yeah, and I have examples of some spacesuits if you want to. If you'd like to take a look at them. Since we're on the topic of spacesuits, I brought some things with me today. This is the coolest piece of hardware that we use in space, and I like it because I can say it's the astronaut's underwear. So it is a, if you can take, if you can see it, and then you can't see it probably from your, you see there's a crisscross in the back. That's a ventilation tree, and that ventilation tree allows ventilation to go through the suit to help keep the astronaut cool. But also we have tubes. If you see these tubes right here, they run in little lines that are threaded throughout the entire structure of the undergarment. We call it the LCVG, the liquid cooling and ventilation garment. And water actually goes through these tubes to help keep the astronaut cool, because it's can get very warm in the suit when you're doing work, say out on space station. And that water circulates in these tubes, and it helps keep the skin of the astronaut cool.
Very cool.
And I have some, let me see, I have a glove. A glove is one of the, this is the inner side of the glove, and it actually is woven to help size it for each of the astronauts. So you can see that, and there's also some configurations in it that help keep the strength of it up as the astronaut works. So it's very, very uniquely, the glove is the only piece of the suit that is specifically sized for the astronaut. And if you ask a lot of our engineers, they might say the glove is the most important part, because they're always using their hands and the gloved hand to do work in space. So,
very cool stuff. And I mean, that's all the inside. You never really get to see the inside of these spacesuits.
Right.
All right. Next question.
Okay. What rockets are presently being developed by NASA?
Well, NASA's currently developing what's known as the Space Launch System. It's going to be the largest, most powerful rocket ever built by humanity. That's being built, so, and it's what's categorized as a heavy lift. So when you want to send people large payloads, things like a habitat to a place like Mars, you need a lot more power to escape what's known as the gravity well, basically gravity pulling you back into Earth. And so the more weight you want to send, the more powerful your rocket has to be. So NASA's developing this Space Launch System. We call it SLS because we love acronyms. We're developing that to be able to basically send anything we want, we can send it to Mars. And I mean, that's going to be the rocket that's going to send astronauts, once we start moving out beyond low Earth orbit again, it's going to be sending astronauts farther than we've ever gone before. Great question.
All right, looks like we got time for one final question.
Okay.
All right. How has mission control changed since the Apollo missions?
It's actually changed pretty significantly. I mean, if you look behind me, you'll notice the computer screen is just kind of like a regular LCD monitor. Back in the Apollo days, you had these massive, massive console systems that used cathode ray tubes and mechana, and they actually had their email system. Was literally just a tube that you stuck through, went down to a mailroom, and they would send that to each other. So it's changed drastically as we get better computers, you know, we get better systems, but it's changed quite a bit. And actually, we're building a new mission control center, which will look even more different than this one. They're doing away with the great big consoles, and it's basically just going to be a bunch of computer screens that are going to be running all of our vehicles. All right, well, I think that's all the time that we have. You guys had some great questions. I hope we were able to teach you a little bit. But thanks for stopping by Mission Control, and hope to see some of you as astronauts in the future.
Absolutely. So good to hear from you guys from Naperville. I'm an Illinoisan myself. I went to SIU, and so I volunteer for this effort today because you guys were from Illinois, and hope to see you guys pursue engineering or scientific degrees to help support the space program.
Okay. Thanks a lot, guys.